Hello all, I am Shatabdi Acharya from Vedang Institute of Technology. In this video, we will be taking up another chapter from your module, which is polymers. Okay. So, before moving on, let us understand the term a bit more. What is polymers? Poly means many, right? So, the word poly means many. And what do you mean by mers? Mers means unit. So, have you all seen the beads or the chains which like women wear around their neck? So, what happens? Small beads are intertwined among themselves to make a necklace, right? So, if I take one bead, that is one unit, and similar units of that beads are repeated to make a chain around that women put on around their neck, right? So, basically poly means many, mers means unit. So, many units are joined together to give you a polymer. If I consider that chain, then that comes out to be a polymer, because very small units are joined together end to end to give you a larger substance. Okay. So, polymers are materials that are used in almost, like, see, polymers, you got a basic idea about what are polymers. Now, whatever in the current trend, polymers are very like widespread. They are used in almost every material which we encounter in our day-to-day life. Say for example, since like every household is aware of the a thing called polythene, which we used to normally carry or bring things from outside, right? Polythene is something which like everyone of is aware of, right? So polythene in itself has a word called poly. Now poly means obviously many units of ethene. Many ethene units are joined together. What is the structure of ethene? That is CH2 double bond CH2. Now many ethene units are joined together to give you polythene, right? So polymers are materials that are used in almost every material we encounter on a day-to-day basis. Today they have particular importance in today's increasingly industrial world. They are often found in the field of science and technology as well as industries also. So you cannot imagine your life without polymers. Now the products made from polymers are all around us. The clothing which we see, the synthetic clothes which we see, the polythene cups, the nylon bearings, plastic bags, fiberglass, polymer based paints, epoxy glue, polyurethane foam cushion, silicone hard valves, Teflon coated cookware. They are like, the list is endless. We can just go on and on where polymers are being used. So that's how polymer is important to us. Now, like polymers in current scenario, we are so much codependent upon the polymer that we cannot imagine our life without polymer. Now, to build or to make up polymers, there must be a process. That process is called as polymerization. Let us see. Polymerization means the process of joining together a large number of simple small molecules to make large molecules of high molecular weight. Okay, basically to join smaller units to build up larger units. Okay, the process of joining together large number of simple small molecules to make large molecules of higher molecular weight, to combine lighter materials to make heavier materials. It is called polymerization. What are polymers? Polymers are those high molecular mass compounds which are formed after smaller units are joined together. So polymers are high molecular mass compounds whose structures are composed of a large number of simple molecules. Okay, so if I'm saying polythene, we just take up the like material and use the word poly. Okay, we take up the compound and use the word poly, we get a polymer. For example, ethene I'm taking, I'm joining ethene end to end, I'll get polythene. So polythene, PVC pipes. Okay, so PVC is basically polyvinyl chloride. Next is bakelite, Buna S rubber, Buna N rubber, Teflon, etc. Okay, these are the examples of polymer. Now the word polymer is derived from a Greek word poly, means many, and mers means unit or parts. Okay, so what, like the individual, the smaller parts from which, or the smaller units from which we get the larger units must have some name, right? So for them we use the word monomer. Mono means single. Now mer means unit. So that single unit from the polymeric chain is called as a monomer. Monomer is the single repeating unit which on polymerization gives a polymer. Okay. For example, here, if I'm saying ethene is a monomeric unit of polythene, that means two ethene molecules or the larger number of n number of ethene molecules are joined together under pressure and some presence of catalyst. They form polyethene. What happens basically? See, normally what happens? The one containing unsaturated hydrocarbons, that is the ones having double bond in between them, they can be used in the preparation of polymers. Why? See, they have the tendency, they are unsaturated, that means they are like the bond is not saturated, that means they have the tendency to further bond together, and we know pi bonds are weaker bonds, so they can break easily. So what happens if I'm saying ethene, this is one ethene, this is another ethene, these break and they give rise to chain of polyethene molecules. Okay, n number of polyethene molecules. So normally alkenes or alkyne containing groups, they have a tendency to form polymers. So here what has happened? Ethene under pressure as well as catalyst and heating, it forms a polymeric unit of polythene. Okay, see here the double bond is broken. The two carbon atoms are linked together by a single bond, and these two further extend the bond, extend this single bond with other carbon atoms. Likewise, the chain goes on. So that's how polymerization occurs. Okay. Now we'll see the classification of polymers, how polymers are classified. First thing we will see polymer classification of polymers depending upon the sources from which they are classified. Depending upon the source, polymer is of two types. One is natural polymer. Natural polymer signifies they occur in nature, right? So example is natural rubber, silk, polysaccharide, starch, cellulose. Okay, starch and cellulose, these are carbohydrates. Okay, they are the polymers of carbohydrates. That's why they are called as, carbohydrate is another name called saccharides. So they are called as polysaccharides, means polymers of saccharides, hence polysaccharides. So what are the examples? Natural rubber, silk, polysaccharide, starch as well as glucose. The next chapter is, the next classification is synthetic polymers. Now synthetic polymers means they are obviously not made in nature, they have to be manufactured. So they are polythene, PVC, bakelite, Teflon, nylon, bunion, etc. Bunion are also rubber, they are synthetic rubber. So synthetic polymers are the ones that are not prepared or they are not naturally found. They have to be prepared in the lab or they have to be prepared artificially in the industries, and the examples are polythene, PVC, bakelite, Teflon, nylon, bunion. Okay. Now this was depending upon the source of origin. The next classification is depending upon the nature of monomers present. Okay. Now nature of monomers, the monomers can be same. Okay. Suppose I am saying polyethene. Polyethene means the same kind of ethene or the same ethene molecule is going on repeating itself in a chain. So the monomeric units are same. For same, we use a word called homo. So if the monomeric units are same, they are called as homopolymers. The polymer containing monomeric units of identical chemical composition or the same chemical composition is called a homopolymer. In other words, polymer formed from one type of monomer is called homopolymer. In which the monomeric unit is similar, they are called as homopolymers. What are the examples? Polyethylene, PVC, polystyrene. Okay. Here, this is, suppose this is the monomeric unit. So, sorry, this is the polymeric unit and each individual M is a monomer. Each individual M is a monomer. They go on repeating themselves in a chain and hence they are called as homopolymer. Next is copolymer. Copolymer means the monomers are different. Okay. the polymer containing monomeric units of different chemical composition, they are called as copolymer or mixed polymer. For example, pterylene is a polymer of two monomers. One is ethylene glycol and another one is terephthalic acid. So, pterylene is basically a polymer of ethylene glycol and terephthalic acid. Hence, it comes under the category of copolymer. The next example of copolymer is bakelite, nylon 66, nylon 610, buna S, buna N, etc. See here what happens? Different monomeric unit M2, M1, M1, M2, M1, M2, M1, M2. Different monomeric units go on repeating each other. Hence, they are called as copolymers. So, basically remember in this chapter what you have to learn is the examples of the particular polymer or to which category the polymer belongs, and in the later section we will be dealing with preparation and uses of these polymers. So, basically if I am taking one polymer, I have to remember the monomeric units from which the polymer is made up of and what are the uses of this particular polymer. Okay. So, this part is very important for this chapter. Next is, depending upon the nature of the polymeric chain or the structure of polymers, they can be classified. Like the nature of polymeric chain, how the polymeric chain is arranged. Based on that also, the polymers are classified into following types. The first is linear polymers. Linear, the word signifies straight chains, right? So, if the polymeric chains are present in a straight line fashion, they come under linear polymers. So, these are the polymers in which the monomeric units are linked to one another to form long linear chains. Okay, and these chains are closely packed with each other. The close packing results in high densities. You have to remember this. If there are linear polymers, then the long chains, they are closely packed with each other. Obviously, if they are closely or tightly packed with each other, that means they have very high density, they have very high strength, or they are very strongly bonded to each other. They have high melting and boiling points. Okay, so these are the properties which are characteristic to linear polymers. That is higher density, higher tensile strength and high melting and boiling point. Okay. Example, high density polyethylene. We have two kinds of polyethylene. One is LDPE, another one is HDPE. What is the difference between them? We will learn in the later sections. So, remember, for linear polymers or the stronger polymer, that is HDPE, high density polyethylene. And next is nylon and polyester. Polyester cloths are made. Okay. So, they have to be strong. Therefore, polyester comes under the linear polymers. Okay, they have high density, high tensile strength, high melting and boiling points. Okay, so high density polythene, nylon, polyesters, these are examples of linear polymers. Now, if I say a linear chain, it somewhat looks like this. Chain like fashion they are arranged. Some part of this is missing of this diagram. Let me do it for you. So, basically, the linear chains are basically arranged like this. This fashion they are arranged. Okay. These are chains of polymers. They are tightly packed with each other, as a result of which they have very high density, very high tensile strength and very high melting as well as boiling point. Okay. Second is branched chain polymers. In such polymers, what happens? Linear means the monomeric units were arranged in a chain fashion. Okay. Branch means, branched chain polymers means there must be some branching. Okay. In such polymers, the monomeric units are linked to form long chains with some branches. Okay. Those branches can be of different length. Okay. Different length with the source. As a result of branching, the polymers are not closely packed. Obviously, if branching arises, the polymer cannot be closely packed. Therefore, they will have lower density, low tensile strength and low melting and boiling point. So, there is a difference between linear polymer and branched polymer. Linear polymers, the chains are closely packed. That is why they had high tensile strength, high boiling point, high melting point as well as high density. And the example was HDPE, high density polyethylene. Now, here what happens is the polymeric chains, they have they are arranged in a linear fashion, as well as there are some branches, and due to those branchings the linear chains couldn't come closer to each other. As a result of it, what happens? They have lower density, low tensile strength, low melting and boiling point. Okay, examples of these are low density polyethylene, LDPE, low density polyethylene, starch, glycogen, etc. Now, if I see the diagram of this, it looks somewhat like this. This is a linear chain with branches. Okay, so this is a branch chain polymer. Next is cross-linked or network. Okay, network means they will be intertwined among themselves. Okay, network of polymers. So cross-linked polymers or network polymers, in such polymers the monomeric units are linked together to form a three-dimensional structure or three-dimensional network-like structure, and these are obviously the chains of polymers cannot be closer to each other, as a result of which there will be they cannot be closely in contact with each other, therefore they will not have high density, they may not be quite that hard, they are brittle. So let's see the link together to form a three-dimensional network-like structure. These are expected to be quite hard, rigid and brittle. Examples of cross-linked polymers are bakelite, glyptal, melamine, formaldehyde polymer, etc. This is somewhat the example of cross-linked polymer. Here the polymeric chains, they are linked to each other at different places. Therefore, they form a three-dimensional network-like structure. Okay. The next classification is on the basis of mode of polymerization. This is very, very important. Now, classification of polymers based on mode of polymerization. The first classification is addition polymer. Okay. Now, what do you mean by addition polymer? See, addition means we are basically, one substance is there, to it we are adding some another substance. Now, when this can be added? When there is some space left in that substance, right? So, if I am considering alkene for example, alkenes are having double bonds. So, that double bond is weak. So, when we are bringing another substance to add on to it, basically the double bond can break and can associate the newer molecule which you are bringing to add on to that particular alkene, right? So, addition polymer is something where there is scope of breaking of that pi bond, and that is basically in alkenes and alkynes, right? So, the polymers formed by polymerization of monomers containing double or triple bonds, basically unsaturated compounds without elimination of simple molecules. Here, in addition, there is no instance of elimination of any simple molecules like water. Okay, so there is no elimination of scope of elimination because there are already presence of double and triple bonds which are available for breaking. Therefore, no other substance or no other atoms need to be broken down or removed from the chain. So, the polymers formed by the polymerization of monomers containing double or triple bond unsaturated compounds without the elimination of simple molecules are called addition polymers. Addition polymers have the same empirical formula as their monomers. There need not be any change in the formula in case of addition polymer because no substance is lost or gained here, right? Because they were having a double bond which basically broke, or double or triple bond which basically broke to accommodate the new atom or molecule which is coming to bond with it. Example is polythene, polyvinyl chloride and polystyrene. These are all double bonding or double bond, like they contains double bond or triple bond among the carbon atoms. Next is condensation polymers. Okay, condensation means decrease in size. Now, to condense, they have to liberate some molecules. This can be possible only where there are single bonds. The polymers which are formed by combination of monomers with the elimination of small molecules such as water, alcohol, HCl, etc. are known as condensation polymers. They are all saturated hydrocarbons. These polymers can be formed by elimination of simple substances like water, alcohol, HCl, etc. These are known as condensation polymers. Example is nylon 6,6 is formed by the condensation of hexamethylene diamine with adipic acid. So, why it is called nylon 6,6? Because hexamethylene diamine, here there are 6 carbon atoms, in adipic acid also there are 6 carbon atoms. So, it is basically nylon 6,6. And when hexamethylene diamine and adipic acid basically combine with each other, they liberate a water molecule. Okay. So these we will be dealing up in detail when we will be dealing up with preparation of polymers. Similarly, bakelite is a condensation of copolymer of phenol and formaldehyde. So bakelite is basically called as phenol formaldehyde resin because it is a condensation copolymer of phenol and formaldehyde. Okay. So here basically we have to remember this, like what does the term stand for and what are the examples. In the next section of this chapter, we will take up a very important part, which is preparation of polymers. So I guess this video is getting lengthy. So in this video, we will be basically dealing with preparation of polythene. In the next videos, we will be continuing with the other polymeric compounds. The first one is polyethylene. Now I have said polythene is of two types. One is low density polyethylene and the one is high density polyethylene. So low density polyethylene is basically the branched one, right? And high density was the linear one, which are closely packed. So low density polyethylene, it is tough, flexible, transparent, chemically inert, as well as poor conductor of electricity. Okay, it's tough, flexible, transparent, inert, as well as poor conductor of electricity. It has moderate tensile strength but good tearing strength. How it is prepared? See, suppose I am seeing polyethylene. Now n number of polyethylenes, they are combining at under 350 to 670 Kelvin. They bond with each other, they combine with each other. There is breaking of this double bond and they form low density polyethylene. If you want, you can screenshot this because this reaction is important for you. Now if I say the uses, it is used basically in the insulation of electrical wires and cables, manufacture of bottles, toys and flexible pipes. Okay, these are the uses of this polymers. So that's all for this video. In the next video, we will be dealing with polymeric substance, different other polymers, how they are prepared and what are their preparation and property. Thank you.